Hello all, and thank you for listening to another video of Mr. Laxton talking through these Algebra II section 3.6 notes. We did skip 3.5. We're just looking at 3.6 today, and we're going to call it good for the chapter. All right, so 3.6, I'm going to be honest with you, is kind of a tough section. All right, it's solving systems of linear equations in 3 variables. So we've looked at solving in 2 variables where we did like elimination or substitution to find out, hey, where did these lines actually cross? So now we're looking at equations with 3 variables. So we're going to find a solution is an ordered triple today. That's an x, a y, and a z. All right, so we're going to find an x, y, and a z today to find out our total solutions. All right, I'm going to be honest with you, a little bit tricky. They're probably one of the most work problems that we're going to do this whole year. All right, so they got a lot of work that goes into each one of them. All right, but kind of some easier ones here as we go on through. All right, so just like systems of 2 equations, I'm not going to spend a whole lot of time on this. There's one solution, that's the normal, what you'll get. There's also infinite solutions where these lines are on top of each other. And there is also no solutions. All right. So, and in 3 systems, or in x, y, and z, we're looking at not just lines, we're looking at planes. So here it says that the planes intersect in a line, all right? Or all 3 planes do not intersect at all. They might be parallel planes or different things like that. All right, so not a whole lot worried about those things. We're just trying to find this x, y, and z right now. Okay, so to solve systems of 3 equations, we can either use substitution, or we can use elimination. All right, and that linear combination method. All right, and you guys are going to be able to see pretty quick and easy which ones you can use substitution for and which ones you have to use elimination. All right, so here, this first one, as we look down into this first one, this is substitution. All right, so this is substitution because I see that, hey, we already know what z is in this first one. We already know that, hey, z is equal to 5. So you can kind of find one of these equations, if it's really easy to solve, like, hey, z is actually equal to 5, then we're going to just substitute that on up to find out what the rest of these guys are. Okay, so we know already that z is equal to 5, so I'm going to take this 5, and what do you think I'm going to do with it? I'm going to plug it into z in that equation. I'm going to solve for my y. So now I get y plus 2 times 5 is equal to 13. So now hey, 2 times 5 is 10, so I'm just going to subtract 10 here to make this a little bit more quick, and I get y equals 3. All right, so now I know, hey, my y is equal to 3, my z is equal to 5. Now I just have to find out what that x is, and able to do that, I have to plug in my y and my z into this top equation and solve for that x. So now I have 2 times x minus 3 times my y, which is 3, plus my z, which is 5, is equal to 10. All right, so all I did there was I plugged in my z is 5 and my y is 3, and I just kind of went on up those equations. All right, and I'm going to substitute them in to find out what these guys are. So now here I have 2x, and then this is going to be what? Negative 9 plus 5 is equal to 10. Negative 9 plus 5 is going to be 2x. This is going to be minus 4 is equal to 10. So now I add 4 to both sides, I add 4, so now I get 2x is equal to 14, divide by that 2, and I get x is equal to 7. Alright, so here we go, I found out what all these guys is, so I need an x, y, and a z for my point, and I know that my x is 7, my y is 3, and my z is 5. So 7, 3, 5. All right, awesome. So that is a substitution one. Not too bad. You kind of just work your way. We worked from down the bottom equation all the way up to the top one. Not always going to be like that. But if you have an equation that says, hey, you already know what one of those variables are, then you can kind of just go through the substitution method all the way up. All right, awesome. So here we go. Example number 2, as you look here, is a little bit more tricky. We have these 3 equations. I just kind of like to label them 1, 2, and 3 just to kind of make a little bit more sense for myself here. I'm going to label those guys 1, 2, and 3 so we can kind of talk about those equations. All right, so this one we're going to have to use the elimination. All right, and here's something that I want you guys to all write down or all remember. You are going to eliminate the same variable two different ways. All right, so we're going to eliminate the same variable in two different ways. And there is an easy way to do this to make it easy on yourself. And if you don't do it this kind of the easiest way, it kind of gets a little bit messy. So here, most examples that I'm going to give you, I'm going to be honest with you, are going to have kind of one that looks like it's going to be the easiest to work with. So if I look here, I kind of look at all my variables. I have my x column, I have my y column, and I have my z column. Which variable is going to be easiest to eliminate twice? All right, and hopefully you should be looking in your head here, where do I have opposites? Where can I make opposites and how can that work? So as I look at my z's, I have 3z and I have negative 3z right here in my second and third equation. All right, so that looks like to me that's going to be easy because I don't even have to multiply any of those equations by something. I can just add them straight down and those z's cancel out. So that's kind of the tough part for you to find out for yourself. Then you have to look, hey, is there another easy way to eliminate that z? And I look at this has got 1z, so I can really multiply 1 by anything to get that something to make opposites. So I'm going to, first of all, I'm just going to take my second equation and I'm going to take my third equation and I'm going to add them straight down. So I get 5x plus 3y plus 3z is equal to 71. Okay. Hopefully I have enough room here to write all this stuff out. Leave yourself some room. So now I have 4x minus 2y minus 3z is equal to 1. So this is nice because I didn't have to multiply any equations by anything. I just took them and I'm going to add them straight down and I notice that, hey, my z's cancel out. So now I have 9x, negative 3y and positive 3y and negative 2y are going to be positive 1y is equal to my z's cancel out, so I have equal to 72. All right, so that's my first equation. All right, I'm going to use that. I'm going to need that. Now I'm going to go here. I have to eliminate z in a different fashion. I eliminated it once. That's right here. I need to eliminate it again a second time. So now I take this equation number 1. I have to use this guy, right? And what can I multiply it by to get opposites? You can either look here if I want to make it into 3 to cancel out with this guy, or negative 3 to cancel out with this. I don't really like the negative, so I'm just going to multiply this guy by a positive 3, and I'm going to add it with this third equation down here. So I'm going to write my third equation. All right, my third equation is 4x minus 2y minus 3z is equal to 1. All right, and I want to try to make 3z right here, so this guy cancels out, and that's what I'm doing. So I'm multiplying this guy by 3. All these guys here. So I'm going to multiply 3 times my equation number 1. Okay, so if I multiply here 3 into all these things, I have negative 6x plus 3y plus 3z, that's what I wanted to make, is equal to negative 6. All right, awesome. So now if I go through and add these guys straight down, this guy makes negative 2x. This guy makes, again, positive 1y. My z's cancel out, which that's the reason why I did that, is equal to negative 5. Okay, so now notice, I'm going to switch my colors here, is that I have two equations right here, bang and bang, and they both just have an x and a y. So now I can just use regular elimination that we've learned about to find out, hey, what are my x and my y? And I know, like I said, I know this is kind of the lengthier process, but I know that we can go through and do this. So now I have this. I have 9x plus 1y is equal to 72. And then I have negative 2x plus 1y is equal to negative 5. Okay, and then now I need to eliminate a variable here. So I look, hey, I'm going to multiply this guy by a negative 1 to make this into the opposite of this. Okay, so now I have 9x plus 1y is equal to 72. And then I have 2x minus 1y is equal to 5. Okay, So notice here, I multiplied that bottom equation by -1. You could have multiplied the top one by -1. That's okay. There's a lot of different places where you can kind of go in your own separate route here. You're going to get the same answer. So now as I add these guys straight down, my y's cancel out now. And now I have 11x is equal to 72 plus 5 is 77. Now this is where you should start to celebrate because, hey, does 11 go into 77 nicely? Of course it does. So my x is equal to 7. That's where you start to celebrate. Hey, you got most of the work done here. So I know that in my ordered pair, my x is going to be 7. I have to find my y, and I have to find my z again. Okay, so I have one part of that answer. Okay, and the nice thing is that, hey, now I can just go through and plug these guys in. So I plug in x equals 7. You can plug it into either one of these equations that I have circled up here. So if I have x is equal to 7, I'm going to go -2 times 7 plus 1y is equal to -5. This is going to be -14 plus y is equal to -5. If I add that 5 over here, if I add the 14 over, add 14, I get y is equal to 9. And where did you go there? And y is equal to 9. So that goes in there. Awesome. And my last part here is I have to find out, hey, what is my z equal to? So that I have to plug into one of these top equations up here. And this one, I look at this one and say, hey, my z is all by itself there. It doesn't have any numbers in front of it. So I'm going to plug it into that one so I don't have to end up dividing at the end. Okay, you can plug it into any of them. It doesn't matter. I just think that one's a little bit easier. So now here I get -2. And instead of writing x, I'm going to write 7 because I know that is my x. Plus my y, which is 9, plus z, which is what we're trying to find, is equal to -2. Okay, and now this is going to be what? -14 plus 9 plus 7 plus z, excuse me, is equal to -2. That's why I write those dashes through my z's so I can make sure they're not 7s. And -14, 9 is -5 plus z is equal to -2. And awesome, awesome, awesome. Add that 5 over to the other side. And add 5, add 5. I get z is equal to 3. All right. Awesome. Again, you can go through and check this. You can plug this, z is 3, 7 is x, and 9. You can plug that into this equation and this equation to make sure that they come out and work. But most of the time, if you get it to work in one of those, it's going to work for all of them. Okay, but good to go back and check your answers to see what you got. All right, so I know that that's kind of a tougher process. I know that's kind of a longer thing, but we're going to work on a lot of these and make some sense out of these, okay? So here, again, eliminate the same variable 2 different ways. So here, I found out that z is easiest, so I took 2 and 3 that eliminated it, and then I took 3 and 1, but I had to multiply 1 by something to get opposites there. So I have these 2 equations, and then I use regular elimination to find my x and my y. All right, and once you find your x and your y, then you go back and plug it into one of those top equations that we started with to find your z. Okay, so find that easiest variable to eliminate, people. Find that easiest variable. There's one that's going to have opposites right away, and then you're going to probably have to multiply 1 by something to get opposites for that second. All right, once you find those, go through and find all your variables and see what you can find. Like I said, I know that's kind of a longer process. We're going to work on those. We're going to make some sense out of that, I promise. And so do your best. Keep working hard. I know you can do it. Thanks. Have a good rest of your day. Bye.